The focus of this lesson is on solving exponential equations that cannot be written in terms of the same base. So the procedure for doing such is to isolate one of the exponential expressions in the problem. So get it all by itself on one side of the equation by undoing the other operations. Once that's done, then you can apply the common log to both sides of the equation, which maintains balance. And then you can use the power rule, which allows you to bring that power down as a multiplier coefficient on your natural log. And then from there you can solve for x using various steps. So we'll go ahead and take a look at an example. We have 3 times 4 to the 2x minus 1 plus 4 equals 14. The exponential expression is the 4 to the 2x minus 1. So that's what we want to isolate. So I'm going to start off by subtracting 4 from both sides of the equation, which leaves me 3 times 4 to the 2x minus 1 equals 10. Divide by 3 on both sides to get rid of that multiplier of 3, and that would give us 4 to the 2x minus 1 when you divide by 3. And then 10 divided by 3 is just 10/3. And then I would apply the natural log to both sides. So it would be the natural log of the 4 to the 2x minus 1 equals the natural log of 10/3. From there I can use the power rule, which allows me to pull my power down out front as a multiplier. So I have 2x minus 1 times the natural log of 4 equals the natural log of 10/3. Distribute that natural log of 4 on the 2x, and I'm going to keep my xp separate, so I'm going to go x times 2 instead, but then multiply that by the natural log of 4 minus natural log of 4 times 1 is just natural log of 4, so that's distributing, equals the natural log of 10/3. I want to isolate the expression that has x, so x times 2 natural log of 4 equals, add the natural log of 4 to both sides, I get natural log of 10/3 plus a natural log of 4. And then last, divide off the 2 natural log of 4. So x equals the natural log of 10/3 plus the natural log of 4 divided by 2 times the natural log of 4. And you could simplify this even further if you like, but you could type it into your calculator straight away and you would get x is approximately 0.93, so 93 hundredths. Let's go ahead and take a look at another example. So in this example, notice that we have two exponential expressions, the 2 to the 2x plus 1 and the 3 to the x minus 1. So it's impossible to isolate them both at the same time, so we need to isolate one of them. So it doesn't really matter which one. So I'm going to start off by dividing by 7 on both sides of the equation, and so that'll give me 5 times 2 to the 2x plus 1 divided by 7 is equivalent to the right hand side, if I divide it by 7, leaves us 3 to the x minus 1. So that isolates that exponential expression like we want, which then allows me to apply the natural log to both sides. And so I'm going to go ahead and write this as the natural log of 5/7 times 2 to the 2x plus 1 equals the natural log of the right hand side, which is 3 to the x minus 1. On the left hand side you have the natural log of a product, so you can write that as a sum of logs, so natural log of 5/7 plus the natural log of 2 raised to the 2x plus 1 equals the natural log of 3 raised to the x minus 1. And then on the left-hand side, natural log of 5/7 is fine as is, but the natural log of 2 raised to the 2x plus 1, we can use that power rule and bring that down. And so this is the natural log of 5/7 plus 2x plus 1 times the natural log of 2 equals, pull down the x minus 1 as a multiplier using the power rule, times your natural log of 3. Then go ahead and distribute. So the natural log of 5/7 equals, distribute that natural log of 2 on 2x plus 1, and you get x times 2 natural log of 2. I like to keep my x separate since I'm going to have to divide that out at some point, plus the natural log of 2 times 1, which is just natural log of 2, equals x times the natural log of 3 minus 1 times the natural log of 3, which is just natural log of 3. Then get your terms that have x on the same side of the equation by using opposite operation. So I need to subtract off x natural log of 3, which causes it to disappear from the right hand side and show up on the left hand side. And then on the right hand side you do have negative natural log of 3 already, but then you need to move over the natural log of 5/7 by subtracting it off. And then you also need to move over the natural log of 2 by subtracting it off. And so on this left-hand side, each of those terms has an x, so we can factor that out, which leaves us 2 natural log of 2 minus natural log of 3 equals negative natural log of 3 minus natural log of 5/7 minus natural log of 2. Divide off 2 natural log of 2 minus natural log of 3 from both sides. That'll leave us x equals negative natural log of 3 minus natural log of 5/7 minus natural log of 2 all over what you divided off, which was the 2 natural log of 2 minus natural log of 3. And you could put that all in your calculator if you like. If you do, I'd probably put grouping symbols around the whole numerator and grouping symbols around the whole denominator. That way it divides correctly. And you would get x is approximately, let's put the little squiggly sign, is negative 5 and 0.06, so 5 and 6 hundredths, so negative 5 and 6 hundredths.